Hi all, in this video we'll be taking a look at how we can design and implement a microservices architecture using RabbitMQ and NodeJS. So RabbitMQ we will be using as the message broker between our services, and NodeJS in which we will write our server-side logic. Now the traditional way of designing an application was something like this. You will have a data source or a database, and on top of that you will have the data layer, or you can call it the data interface, and on top of that you will have something like the business logic, so which you will be using some server-side language for that, and the UI to invoke all this. So there are many pitfalls to such a stack, right? So the entire application is one extensive system based on a single code base, and the server-side application logic and client-side logic are all in the same code base. So basically microservices, they build applications on smaller services that operate independently and in isolated logic, with each service having its own code base. So if one service fails in this architectural style, no significant effects are seen on the service because they are built autonomously and operate independently. Now, some of the key advantages of microservices are as follows: scalability, technological mix, and solidity. That is one of the most important features that I like. So unlike a monolith, the failure of a single service has no negative impact on other services in a microservice. Now, scalability is another thing. Microservices enable cross-functional teams to update services independently, and scaling has improved performance, reusability, and distribution of the load. And microservices, in my opinion, are easier to deploy. At first glance it may not be, but as you get familiar with the architectural style, this is pretty easy, and this is very decoupled and easier to debug, easier to easier to keep track of, I would say, right? So RabbitMQ acts as a message broker between the services. I'll give you a simple example, or I'll show you visualization. Now RabbitMQ makes use of the AMQP protocol. So AMQP is nothing but advanced message queuing. So that is a protocol something like HTTP, right? But it's different. It differs in the way in which it is structured. So in AMQP you will have a producer, and the producer is the producer of a message, right? So it may be a product service in which you are using to buy some products maybe, and you will have an exchange, right? So the exchange, and then you will have the queue, and in the queue you will be creating something you will be pushing messages into the queue. So the queue acts as this thing that stands between the producer and the consumer. Now the producer will be one service and the consumer will be another service. So this service may be in the same code base or in a totally different code base. It may also be a service that is written in a totally different language. For example, the producer can be your NodeJS method, and the consumer may be a function written in Java, right? So this is a very good use case of why and how you can use RabbitMQ as your message broker in your microservice architecture. So let's take the simple example of a product service. So the product service in our use case is used to add products and buy products, right? So the product service will have a route to add as well as buy, and when we buy the product using the product service, we will push to the order service queue, right? So we will create a queue and we will push our data to the order service queue, right? That is all the product service will do. And now this order service, this completely independent order service, which is another service written in Node.js, this will listen to that queue. This is the subscriber, right? This is the consumer of that particular queue. Now when something is pushed to that queue, since the order service is listening to that particular queue, this queue will have the data of the products, and once the data is received in the order service, it processes the order inside the order service, right? It has products, it has the quantity, it has the price, and it processes the order. It creates a new order and pushes it into the database, and then it gives a callback, or it gives a message back to the product service queue saying that the order was successfully processed. And what the product service will do is, once it gets back the message or the confirmation that the order details have received, it will acknowledge it, right? So acknowledgement is nothing but the service telling that the message is received, and now once it is acknowledged, the data from the queue will disappear, right? So that is for another video, but you get the gist of it, right? So this is basically the diagram. Here we'll have the buy request from the product service, and the customer, after this thing finishes executing, the customer will have the order confirmation or the invoice or something like that. So this is what we'll implement in our Node.js application, right? So let's go ahead and get started. We'll have the product service directory inside of our folder, right? So inside product service, you will have to install a couple of things. So we'll use npm to do that. I hope you have Node.js installed. So npm -y. So this will initialize it inside product service directory, and you can see that package.json is created. Now npm install mongoose. We wanted to store data from store data into our MongoDB data, local MongoDB compass, right? And AMQ lib, it is the npm package for us to use AMQP, and Express will be our server-side framework for Node.js, which makes things really simple. We will be writing a couple of services to create and buy products, just like I mentioned earlier, right? So const mongoose is equal to require mongoose. So this is pretty much standard Node.js boilerplate code. And so what we are doing here is we are constructing a schema for product. So basically, what product collection inside of our database, what all attributes will have, and what are the requirements for those attributes. So a product will have a name. We won't give too much importance for the schema. We just need a couple of fields for this one tutorial, right? So type string required true for the name of the product, and we will have a price. These two are the most important things. I think this will be it. Maybe we'll add quantity as well. So type number required true, and let's say I need quantity as well. I don't think I'll be using quantity. I'll insert it into DB, but I will do the quantity check in a later video, because I want to check for the quantity when someone presses the buy button, right? So yeah, that we will do anyway. So for that we will add quantity, and timestamps true, and let's export this schema. So module.exports is equal to mongoose dot model. We will call it product with capital P, comma product schema. Okay, now we want to create a route. So let's create a folder called routes. Inside we'll have a routes.js, and here we need to require a couple of things. So const router is equal to require express dot router, I think. Yeah, okay. And const router is equal to new router. Okay, now what do we need? We need const product is equal to require. We need to require the routes, right? So let's require that. We need AMQ lib, AMQP, right? So const AMQP is equal to require AMQP lib. Just make sure you put some meaningful names when you require this things. You don't have to follow all this. Okay, so let's say async function, we need to establish a connection to RabbitMQ, right? So connect to RabbitMQ. So to establish the connection to RabbitMQ, we can say const AMQP server is equal to. So RabbitMQ is usually started on port 5672, I believe. So in our case we will be using 5673. Let's 572 or 5673. That is the default. I mean, you can change the port to whatever you want. Once you start the RabbitMQ server, you can change the port. We will be using Docker to do that. So I mean, let's just put 5672 for now, and we'll have a variable connection outside of the function because we'll be reusing that variable elsewhere. So connection is equal to AMQP server dot await AMQP dot connect AMQP server. So here in the await you will get the connection. Okay, now we need the channel, and we will say channel is equal to await connection dot create channel, and we need to assert the queue with this channel. We need to create channel and assert the queue. So await channel dot assert queue, and we will name it product service queue. Just be careful with whatever name you are using, because once the queue name is different, the whole thing will go. It is better to define a constant with these queue names, but for this tutorial we won't be doing that, and we will call that function connect to RabbitMQ. Let's just call that function once this route is there, right? So let's create a product. So create a product. First we need to insert that product into MongoDB. So router, we'll use that router.post slash. So this will be async, and it will have a request and response as the params. So here you can see that name, price, and quantity is what we need to enter the product. So let's destructure it from the request.body. Okay, pretty simple, pretty standard stuff if you ask me. And if we will want each of these to be there, so let's say if none of these or if any of these are not there, we will throw an error. We will say that we cannot enter the product into DB. We will not be saving product. So return rest.status 400.json, we'll say message, we'll throw some message, please provide product details. Now if it is not the case, we will say const product is equal to new product, and here we will give name, price, quantity. Okay, should we use await there? Yeah, let's use await. So here, why is it giving me an error? Okay, I need to give async. Sorry, I forgot about that. And await product.save. So if everything is good, we will have the product in the DB. Save product to MongoDB. Okay, and then let's see what we have to do. Yeah, so once the product is saved, we will say res.status 201.json. Let's give back something to the user. We will say product created successfully. Now what we want to do is we want to buy. Okay, this is where we will be using our queue to send this data to order service queue. So this is where the microservice architecture actually comes into play. So let us see. So when the user wants to buy something, let us say the user will pass product IDs from the front end, right? So let's destructure product IDs from request.body, and from these product IDs we want to see which all products are there. So let us fetch everything that has these product IDs from Mongo. So we will say const products is equal to await product dot find, where product is the model, which is our schema for product, dot find, and inside parentheses we will have underscore id and dollar in product id. So it will fetch everything that is inside of product IDs. Okay, so yeah, and once the products are fetched, we want to send this data to be processed in the order service, which is a totally different service, right? It does not live inside this application. So I will say channel.send to queue order service queue. Okay, order service queue, and buffer.from and json.stringify. So we want to stringify the data, otherwise it will throw an error. Products. Okay, that is all you have to do. This is pretty easy stuff. And once you get back the order confirmation, once the order is processed, we will listen. So we want the channel to consume product service queue. We'll be doing it from the order service later, and we'll get back data. And what will be the data? The data is nothing but the order details. So we will say console.log consumed from product service queue, right? And then let's see, order, or wait, where is this? Okay, order is equal to json.parse data, because we can only send stringified data through the queues, right? So we can acknowledge the data. So this is also an important step, and that's it. And then we will give back the response, rest.status 201.json, and we'll give a message, order placed successfully. Should we give back anything? Yeah, and let's give back the order. So once we test this, we can see this in our console, and this we can use it to do different things, right? Okay, so now we want something to use these routes. So let's create in the root directory index.js file, and here we will require a lot of stuff. So this is also pretty standard Node.js boilerplate stuff. If you need a separate video on that, do let me know in the comments, guys. Const express, we need to require express. We will say app is equal to express, and we will say in which port we want to run the service. So fetch it from the env.port or 3001, and require mongoose. Need to establish connection to the DB. Actually these should be different separate files, these DB connections and all, but we don't have time to do that. Let's require the product route from /routes, and app.use express.json, okay, and we will say app.use express.url encoded extended true. Now we will need app.use, let's see, sometimes boilerplate can be quite confusing. Okay, so /products will be product route. So what are we defined inside our routes, right? So to access that, we will have to say localhost /products/by and localhost /products/ to save the product. Okay, now let's connect to Mongoose. So the default MongoDB URL will be MongoDB /0000 port 27017 / scan product service. So that will be a name of our collection. And these two params, I am not sure if we need it in the latest version of Mongoose, because I think they are deprecated. We will test them when we run the app in a short while. So we will say .then, and we will console.log product service connected. Okay, and in the error scenario as well, if the connection somehow fails, if the Mongoose connection fails, we will catch the error and we will console log the error. Okay, and then you want to say app.listen port console.log product service running on port. Okay, so that's it for the product service. And let's create another service called order service. And in order service, let's open this in the integrated terminal, and npm -5 we need to repeat a couple of steps, and npm install mongoose amq plib express, all of the good stuff again, right? So let's create a directory models. In the model we'll have order.js order schema. So again, const mongoose is equal to require const schema is equal to mongoose.schema, const order schema is equal to new schema, and what all will the product have. So I mean the order will have products. So products will be a list of products, so array of products. And what will the array of products have? It will have what? It will have product ID, right? So product underscore ID will be what will be in the array, and it will be a string. And then we'll have the total, and type will be number. We'll just do a quick calculation of what will be the order total, and this will be required true. That's all we need for order for now. And here again we'll say timestamps is equal to true, and let's export this order. So module.exports is equal to mongoose.model order and order schema. So I will leave this docker compose.yml file. This is nothing but we need to start up this this thing, what do you call, RabbitMQ server, right? So RabbitMQ server will be running on port 5673, and we need that. So we'll be using Docker to do that, to run the RabbitMQ service. So here we will say port number 5673 instead of 5672. And for order.js, for order service, yeah. So let's see Docker compose up. Let's just test it out, and here you can see the RabbitMQ image is being pulled by Docker, and we will have it in our local up and running. I'll show you in a minute. And let me just run the product service. So node file name product service successfully running, and if you go to localhost 15673, you can see the RabbitMQ is up and running. So the overview. This is the dashboard where you can have a quick overview of what all queues are there, what all messages are being exchanged, and here you can see the connections that are made. As you can see, already there is one. Here there are the exchanges. Lot of very useful information in this GUI. And in the queue you can see that product service queue is there, what we created. Very nice. It doesn't have any messages currently, but this is a very nice GUI to keep track of what and where all things are there in what all queues. So in order service, let us create index.js. So this will have a lot of similar things which are there in product for product service. Let's copy paste all that because we don't need to waste any more time. So what else will it have? Let's take all the good stuff. It'll have this. It'll have this as well. We need the Mongoose connection also, right? Yeah, of course we do. We'll rename scan product service to scan order service or something like that. Yep. Okay. And so connect to RabbitMQ then channel.consume order service queue. So here you can see that we have created a queue or order service queue to which we are pushing from product service, right? And we will connect to RabbitMQ.then and we will consume it from our channel. So this will have a data and we have to get our products from that queue. So JSON.parse data and new order will be create order of from the products. So let's create a method called create order. Create order is equal to, it will take products as argument, and using the order schema we will save it to our database. We will save our order to the database with these products. So we need to calculate the total. So we'll say that total is equal to 0 and we need to loop through the products. So products dot for each element we will say total plus is equal to ELE dot price. So once this loop completes we will get the order total. Very easy stuff. And below that const order is equal to new order, and let's pass something. What does order need? So order needs products and total, which we have in the above lines of code. Beautiful. And this will be async as well, and here we will say await, and we will await order.save because these might be, we need to await them, otherwise it will throw an error. These operations take some time. In the time is of milliseconds, but that is what counts. And here we will acknowledge the data. So channel.ack data, and channel.send to queue, send to product service queue. What we will send? We will send the order. So buffer.from json.stringify new order. That's it. I think this is all that we need. And here we can give a response. So once this is given, we will say okay. We'll paste this at the top. Okay, we don't need to give back anything. We will say order service will be listening at port 3002. I think we can test our application. So let us open it into two separate terminals and run both node index.js in the one and in the other, so you can see product service on port 3001, order service on port 3002. Let's open any HTTP client that you require. Let us open Postman, and here let's add a new product. So let me name the product Apple iPhone 15 Pro. Price, what will be the price? Let's say 99,000, and quantity of 10. Send. Okay, product created successfully. Let's open our DB and check if the product is created or not. Where is the DB? MongoDB client, where are you, my boy? So here you can see Samsung Galaxy S24 is already there. Refresh it and you can see iPhone 15 Pro added to our DB. Very good. So first part is working, and now we will take that product ID and we will paste this, and order placed successfully. And here you can see that the order is created, order is placed successfully. We are getting back the order. Let us try for something else. Let us add another product. What will we add? Give me some suggestions. Sennheiser, the headphones, TX100, price will be 12k, quantity 5. Send, product created successfully. Refresh DB. Sennheiser, copy product ID. Let's place an order for 2 products. Let's see if multiple products are working. Comma separated values. Okay, so Sennheiser TX100 is working as well. So here, let me take that product ID and pass it here for 2 products. Send, order placed. Oh, this is very fast. Let's see if it is working, and you're getting back the order. So this is working very beautifully. As you can see, both the products order has been placed, and our microservice architecture is working very beautifully. So that's it for this video. We will build on this in the next video. Until then, take care. If you have any doubts, please leave them in the comments. Goodbye.